This is 1.9 of GCSE Math, multiplying and dividing decimals, and really the logic is the same really for both. We'll start with multiplying. What we want to do both with multiplying and dividing, but we'll show you multiplying first, is remove any essence of decimals throughout the whole working out process and only add it in to the answer at the end. And what I mean by that is this. You might know, for example, if I do 30 times 40, a way I could do this is do 3 times 4 is 12, and then I have 1, 2 zeros that I can add at the end, so the answer is 1200. And you can kind of do a similar thing with decimals. If I have 3.2 times 6.4, I can say that that is 32 times 64 divided by 100, because I've multiplied this 3.2 by 10 to get the 32, this 6.4 by 10 to get the 64, and so because I've done 10 times 10, I have to divide by 100 to balance out. But of course, you don't need to know that every time. What you can just do is do 32 times 64, and then a way to divide by 100 is whatever your answer is, to move the decimal point back 2 places. And that will divide something by 100. Let's divide by 10, let's divide by 100. So what you can just do is 32 times 64, and then you see 2 digits after the decimal point means that 2 digits should be after the decimal point in the final answer, and I'll show you what I mean by that. If I have 1.2 times 1.1, that is equal to 12 times 11, which is 132, and I have 2 digits after the decimal points, and the 2 numbers being multiplied. So 2 digits should be after the decimal point here, the 3 and the 2, so I put it here. 2 digits after the decimal points, 2 digits after the decimal point, the answer is 1.32. And that works for anything. So if I have 2.5 times 2.4, I can do 25 times 24, as in ignore the decimal points at first, and 25 times 24 is 600. And I have 2 things after the decimal point here, so I need 2 digits after the decimal point here, 6.00, or just 6. Let's do another one. If I do 1.37 times 1.1, that is 137 times 11. That's the first thing we've got to do. So if we do 137 times 11, which we do normally, that would be 137 there, and that would be 1170. And if I add it up, I would get 1507. Obviously, if it's calculator paper, you can just use your calculator, but that's just called multiplication. So I have 1507. I have 3 things after the decimal point, 3 digits after the decimal point, so I need 3 digits after the decimal point here, 1.057. And you can roughly check that's right because this is about 1.5 and that's about 1. So your answer should be about 1.5, which indeed it is. So you can do a sense check. We'll do one more. If I have 6.13 times 0.4. Again, we're going to ignore all decimal points, so we're going to first look at 613 times 4. And I can just do that on the side here. 3 times 4 is 12, carry 1, 1 times 4 is 4, plus the 1 is a 5, and 6 times 4 is 24. So 2,452 is what we're working with. 1, 2, 3 digits after the decimal point, 1, 2, 3 digits after the decimal point, it goes here. The answer is 2.452. We can roughly check that. This is roughly, that means roughly equals to 6 times 0.5, we sort of estimate, which is about 3, and 2.45 is about 3. So that's how to multiply decimals. And dividing decimals is a similar logic, in the sense that we are going to ignore decimal points throughout the whole question. So if I have, for example, 3.2 divided by 1.6, we know we can write things as fractions when we're dividing. We've established that many times, so that's this. And as long as whatever you do to the top of the fraction, do to the bottom of the fraction, it remains equal. So I can multiply top and bottom here by 10, and thus remove the decimal points altogether. And then you just have 32 divided by 16, which is 2. You can simplify that by 2s if you want, but you can just do 16 in one go. Let's do a couple of examples. If I had 4.88 divided by 1.2, I can write that in its fraction form. And then here I'd have to times top and bottom by 100 to move the decimal point 2 places. So I'd have 488 over, if I move these 2 places, there'd be a 0 in the gap, so 120. And that's just a normal division, it's 488 divided by 120, so divide top and bottom by 2. and by 2 again. In fact, we can do 4, but if you need to do 2 twice, that's fine. So I now have 61 over 15, and that can't be simplified anymore, so now I can do a bus stop thing if you want, or do whatever, but 15 goes into 64 times, remainder 1, so the answer is 4 and 1 over 15, because there's one remainder there, and so there's your 15th of the way along to the next multiple of 15. We can do another one. If I do 10.32 divided by 1.22, right as a fraction, times top and bottom here by 100, get rid of the decimal points, and then we can get divided by 2 again. 61. Okay, this is not a very nice thing to do, but I can. Bus stop's not going to work here, so I'll have to sort of just write out the 61 times the table a bit. That'd be 122. This would be 183, 244. Let's keep going. This would be 305, 366. Still would keep going. 47, 488, and the next one would be 549. Okay, so this 516 is in between this one and this one. 1, 2, 3, 4, 5, 6, 7, 8. So it's between 8 and 9, so the answer is going to be 8 remainder. I've got 488, but this is 516. So we just subtract them. That becomes 10, that becomes 4, 28. So 8 remainder 28, or in fractional form, 8 and 28 over 61. And that'll be our final answer, and that is all there is to 1.9. See you in 1.10.